Hello everyone, welcome back to this HCO course. In this video, I'll be explaining how we can do sorting in C++ using custom comparators, which are comparator functions given by us. So I'll be taking the help of a problem, sorting rows of numbers from the IARCS OPC judge problems. This is an excellent set of problems which you should try as they are similar to those which come in the Indian Computing Olympiad. So in this problem, we are basically given several lines of input where each line contains a sequence of positive integers. We need to sort these lines in lexicographic order, where lexicographic order is the dictionary order and the ordering method is given over here. We need to choose the elements from left to right, and the moment when the elements from left to right are not equal, we need to choose whichever is smaller and place that before the other one. And in case all the elements are equal, we need to sort them by lengths. So for example, let's say that these are the lines. Then it's clear that the first line will be this because 14 is the smallest. Then the next one is 17. Then the next one is 27. But among 27, you need to choose the one with the smallest length because there is no number after 27. So there's just a single value 27. So you will put that first. Then you will pick the one which has the smaller second value. So that's 12. So that's why 27, 12, 34. Then 27, 34. And then comes 92 because 92 has the largest first number. So in this manner, we can sort them the way they will appear in a dictionary. And we need to do this for only one test case. And in that test case, we are given the integer n containing the number of lines of input, and we are given the n lines of input. The ending of each line is a positive integer -1. So in this way, we know how many integers we need to take. We should not add this to the sorted to the row of numbers. We should just know that whenever we get a -1 in the input, we need to stop taking in the numbers and go to the next line. And this is the example which I just explained. So now let's try to understand exactly how we can write our custom comparator which implements this dictionary sorting order. So the custom comparator returns a Boolean value which denotes whether the element A should come before the element B or not. So the simple custom comparator or the default custom comparator which we use for sorting an array is we pass two variables int A and int B because int A and int B refer to two numbers in the array and we are comparing the two numbers and we are returning true if A is less than B and false if A is greater than B because we know that A will come before B if A is less than B. So the number A will come before B if and only if A is less than B, and this basically means that we will return true to denote that A comes before B when A is less than B, and this is the default custom comparator. However, the custom comparator which we will use for our purpose over here, in which we sort the rows of numbers, will be we will take two vectors, two vector ints, two arrays basically. Let's call the arrays A and B, and we want to return whether the array A is lexicographically less than the array B or not. And in order to do that, we can't just simply return A is less than B because you could do that, but I want to show you how we can write it as a custom comparator. And the way in which we write it as a custom comparator is, let's consider the two arrays A and B. Let's just take two arrays A and B and we go from left to right, checking each and every element. So let's say A has length A dot size and B has length B dot size. These are the two lengths of the arrays or of the vectors in this case. And we know that we will go through all the indices one by one up till A dot size, and over here we'll go through all the indices one by one up till B dot size. Now let's take two same indices. Let's take an index I in the array A and the same index I in array B, and we know that the first index I, where A of I is less than B of I, if we get such index I, which is the first index, we will just return true, that A should come before B. So for example, when A of 1 is less than B of 1, we'll return true. However, if A of 1 is greater than B of 1, we know that B should come before A. That's why we'll return false. Returning false means that B should come before A and A should come after B. So that's why even in the default custom comparator, when A is greater than or equal to B, we'll return false because we know that A should come after B when A is greater than or equal to B. And in this case as well, when AI is greater than BI, we will return false. Otherwise, we will go to the next index of I. So when AI is equal to BI, so when A of 1 is equal to B of 1, we know that we can't check for these two values. We know that these two elements are equal. That's why we go to the next element and we will just increase I by 1 and we will check the next value of I and we'll continue the loop. Now, if we have reached the end of the arrays, if we have reached the end of array A, for example, and let's say that the array B is bigger, then the loop will get over. So the loop will run while I is less than A dot size and I is less than B dot size. So while the index I is less than both their sizes, we will check whether there's any discrepancy in the values. If there is no discrepancy in the values, if the values are the same for each and every element up till the size of the smaller array, then we will return true if the smaller array is A, and we will return false if the smaller array is B. So this is the final return statement. If the vector A is of a smaller size, then we know that A is lexicographically smaller because it contains the exact same elements as B but a smaller number of elements. So up till the end, all the elements are the same as the elements of B, and that's why we will just check whichever one is smaller and we'll return the true if the smaller one is B, if the smaller one is A, and false if the smaller one is B. And this is the entire custom comparator. So now I'll show you the code which writes this custom comparator, and then the main method which handles the sorting is just very straightforward. We'll take in the input, we will add all the elements in the input to a bigger vector of vectors, and we will sort the vector of vectors using this comparator function. So let's look at the code which implements the exact same idea. In the code, the custom comparator is labeled as comp, and you'll pass in comp for sorting this vector of vectors G. So let's first look at the custom comparator which I just explained over here. The logic is exactly the same as the pseudocode. While the index I is less than A dot size and less than B dot size, if A of I is less than B of I, A will be lexicographically smaller. Otherwise, B is lexicographically smaller. And if we don't get any discrepancy in AI and BI values, once we reach the end of one of the two arrays, then we will just return whichever vector is smaller, because that vector should come earlier. And just to remind you, this returns true if A should come before B, and returns false if otherwise, when A should come after B. So that's why we return true when A is smaller than B, and we return false when B is smaller than A. Now in the main method, I take in the value of n, I store all the vectors in the global vector, in the bigger vector G, and you can see this is the format of the input where we take all the values in the current vector. This is the current vector, current row of numbers. We keep taking in the values in the current row of numbers while the elements are not -1, and we push back the current row of numbers to the final to the full set of rows of numbers, and we sort all the rows of numbers using the custom comparator, and then we just print each row of numbers in this set of row of numbers in this manner. And now I'll just submit this code over here to see that it gets accepted. So as you can see, my code got accepted. There was only one small error of not incrementing I in the while loop, which you should have noticed when you were seeing the code. So I hope you like this problem and my solution. If you have any doubts in any part of the solution, do leave them in the comments down below. And if you like this tutorial on sorting using custom comparators, don't forget to give this video a thumbs up. Thank you.